Okay, this is going on page 43 when we're done. Yesterday we talked about the remainder theorem. Today we're going to talk about the factor theorem. They're very much related to each other. So what the factor theorem says is that given a polynomial, polynomial f of x, x minus c is a factor if and only if f of c equals 0. Okay. And that if and only if, that's from some logic statements and geometry, right? It's a biconditional, means that, it has to go, you have to be able to read it forwards and backwards. The converse, the statement and its converse have to both be true. So what this basically is saying, so I'm going to start off with just something super simple over here that we can factor. We got f of x is equal to x squared minus x minus 2. Okay, so let's say that we have that. And we want to factor it. So we factor it and we get x and x, and then it's going to be x minus 2 and x plus 1. Do we all agree with that? So this is our f of x. So these two things are factors. So what this is saying is this is a factor if and only if I substitute in 2 and I get 0. Well, that's why we take this and when we're solving it, we set it equal to 0. And then we say, all right, well then x minus 2 equals 0 and x plus 1 equals 0. Right? So then x equals 2 and x equals negative 1, right? That's actually all of the work that goes to it. We kind of skip this step and, maybe skip even this step just to write that. But that's what's actually happening. Does that make sense? So if I substitute in 2 into here, I'm going to get 0. And if I substitute negative 1 into here, I'm going to get 0 because it's the zeros of the function. It's where it crosses the axis, right? So what this factor theorem is saying is what we've kind of known all along. These factors mean that this has to be true. So now we're going to have, we're using the factor theorem to determine which binomials are factors. So I want to know if it's a factor or not. We've talked about this as well. When we were doing synthetic division, and I told you when we get that remainder is not always 0, but if it is a 0, that means that thing is a factor, and if it's not a 0, then it's not. So this is just kind of, now we're going to use it to basically answer that question, even though we can already do the synthetic division. So we're going to use it and we have to check all of these. When it says check all the apply, it means literally like put a check mark, but we have to check all of them or test all of them. So we could substitute numbers in, but when we're going to start with number 2, we're not going to start with number 1. You really want to substitute 7 into that thing and figure out if you get 0? Because I don't. So we can use synthetic substitution that we learned yesterday, which is just synthetic division. Ignore this random 3 here, because in the program I use for this, either things disappear, sometimes things just magically appear. I have no idea where the 3 came from, but just kind of write over it and you're good. So we are going to test this first one, which means we're going to do synthetic division and basically synthetic substitution. So on the outside here, I get a 2, and then my coefficients are 1, negative 6, negative 17, 78, negative 56, and 0. Yes, you cannot forget those zeros, right? You have to have a 0 for the constant term. Okay, so then we just run through the synthetic division. So we get 1, 2, negative 4, negative 8, then negative 25, negative 50, 28, 56, 0, 0, 0. Okay, so what does that tell you about x minus 2? It's a factor. So we're going to say x minus 2 is a yes. Okay, that has to be there, right, like right next to your little work, and we'll put a little check there. Okay. So now we have to check 7. Okay, but you got 2 options, and the second one's better than the first one. I am going to put a negative 7 out here for sure. Right? But then the numbers that go in here, yes, I can use these same ones. 1, negative 6, negative 17. I can use all those because that's the original, right? But since this is a factor, didn't I pretty much just factor it out? And when I factor it out, what I'm left with, okay, this is 1, 2, 3, 4, 5 terms, which means it's to the 4th. So I'm left with x to the 4th minus 4x cubed minus 25x squared plus 28x, and then there's no 0. Like, isn't that what that means? So this times x minus 2 is going to give me that original one back. So instead of using the original one that has more numbers and bigger numbers, basically I've reduced it down a little bit. And if x plus 7 is a factor, that means it's going to have to factor out of this. Does that make sense? Because it's part of the original. So I can use the reduced form. 1, -4, -25, 28, and 0. And you do not have to write this part out. I just did because I wanted to make sure that, you understood what was happening here. If you do it, if you use the original ones I have in pink, you'll get the same answer, whatever the answer is to this. This one's just going to be easier. Okay? So now I bring down my 1. This gives me -7. Then, no, it doesn't. It gives me 1. Sorry. When I bring down my 1, I get 1. I know, but I wrote it in the wrong place. Then I get -7. There you go. Then I get -11, 77, then what? 52. Is it -364? It is, yeah. Negative. Now, and yesterday in 7th period when I was talking about let's work smarter, not harder, and somebody was like, how do you know how to do it the easier way? Well, personally, I do it the same way every single time. I mean, I'll tell you about different possibilities because I know different things make sense to different people. But the option you have, like if this was a 9, I could multiply this by 10 and then subtract one of them. I rarely do that. That's just not how my brain works, but it does work very well for some other people. I always split it and just do 7 times 50 is 350, 7 times 2 is 14, so that 14 and 350 gives you that -364, okay? Then when you subtract, here's the kind of thing where when you have to borrow and y'all are trying to do it in your head, you mess things up. And again, there's nothing wrong with writing things down. But if I take, I know I'm going to subtract, and I'm subtracting and it's still going to be negative. So, but I'm basically doing 364 minus 28. So I would do 364 minus 20. So now I'm at 344. Then I subtract 8. So that's going to give me the 340, and then 4 more gives me 336. You see how you kind of break it up and do it in pieces? Think about if you were making change or if it's money and how you're going to break it up that way. It makes it a little bit easier. So now I have to multiply these. Well, again, negative times negative is going to be a positive. I know that much. And then 7 times 300 is 2100. 7 times 30 is 210. 7 times 6 is 42. And then I just add them up. That's going to give me 2352. Okay? So this gives me 2352. Now, because of the nature of the question, does what this number is even matter? Nope, because if it wasn't going to, clearly it's not going to be 0, which means it's not going to be 0. Does that make sense? But we still need to know how to do those things. So then that means that x plus 7 is a no. Right. So I'm going to put an x there. Where are you stuck? It's okay. Why? No, I don't understand how you're able to use the smallest factor. Okay, because when I factored this, since x minus 2 works, this is what I get. So this times x minus 2 has to give me the original. So if I guess in my head I'm just thinking, so like let's say the original, like hypothetically. Mm-hmm. Yeah, hypothetically, you're good. So like let's say the original, that whole thing, let's say equals to 12, right? And x minus 2 somehow equals to 6. Well, 12 divided by 6 is equal to 6. But 3 is also... Wait. No, it's okay. Wait, stop, pause, back it up. When you said the whole original thing equals 12, is that what you're saying? But it doesn't. It equals 0 when we're solving. I understand what you're saying. Look, okay. Right, okay, but back up. If I substitute 5 into this, I'm going to get a different number than if I substitute 5 into this. You are 100% right about that. I'm not substituting anything in. I mean, I know this is called synthetic substitution, but I'm factoring things out. And since all I care about is it equaling 0, once I factor this, like let's say that this was a yes. Let's pretend like this was 0, okay? So then that would mean that now what I know, since I reduced it, is that x minus 2 times x plus 7 times this right here would give me the original back. Basically, I'm taking pieces out. So when it's a yes, I've reduced it down. It's like reducing a fraction. Okay? I just, in my head, like 2 and 3 are both factors of 12. Right. 2 times 3 is not 12. Right. You're correct. But see, 2 times 0 is 0. And we're not equaling 12, we're equaling 0. So that zeros, so I know that this is a 0 term. Does that make sense to you? So that works. Okay, and then again, do you understand that when I do this and I've factored it out, that these two multiply back to give me the original? So if I continue to let's say I could factor this by hand, which I can't. Then I would continue factoring from here. I wouldn't start back at the original, so then x plus 7 might be able to come out of it. But all the factors are going to have to come out of this one because this one's already gone. Like he's taken care of. Now I got to check the rest. Then that one's taken care of. Does that help you a little bit more? Okay. All right, so now this one's a no. Now when I use my next numbers, okay, on these, I do not get to use these. That's a big fat no. Again, I could start from the very beginning again, but those numbers are bigger. But I know that this is one of the reduced parts, so I can use these numbers again, basically the ones I just did here, since that one didn't work. So on the outside, I'm going to have a -4, and then I'm going to have 1, -4, -25, 28, and 0. Okay. Then, I'm going to run through this, so this will give me 1, -4, -8, 32, 7, -28, 0, 0, 0. So that means that x plus 4 is a yes. Okay, and then just for clarification purposes, let's say that we had another one to check. If I had another one to check, I could now use these numbers. Because now what I know, which is not something you have to write for this, but let's just make sure we understand what's going on. I've got x minus 2, that's a yes. X plus 4 is a yes. And when I multiply that by this is 1, 2, 3, 4 terms, so that means it's a cubic. X cubed minus 8x squared plus 7x. If I multiplied all that back together, I would get my original. Okay? I crossed it out, thank you. I don't know why I did that. Oh my goodness. Okay, yeah. We want to make sure we answer the question correctly. There you go, after all that work. Mm-hmm. I wouldn't use this. Wait, I wouldn't use this? Oh, no, because I reduced it again. Does that make sense? That's why I didn't. So at this point, we knew this much. And then when we got here, we factored that part out, and that's why it changed the second one. Okay, does that make sense? We were kind of reducing and reducing some more. Okay. Anything else? Those are good questions. Okay. Processing over there. Do you have a question? Yes, we were all watching him drinking his milk. No. Do you have a question? Got it? Okay. Oh, yeah.
Just because, I'm kind of like Michael. It's like, okay, we're like now.
Yeah.
And I got a different answer, but it's just because I was just
Okay, it's all good. You're not stupid. You're human is what it is. But yeah, so if you use the original one, the numbers down here will look different because basically then all you would have factored out was the x plus 4 also. So you would have something different down here than we do. But okay, we good? All right. So let's flip it over on the back. So I was trying to shorten this sum, and by doing that, I completely took off the instructions. So I'll just tell you what they are, and they're on the homework. But the instructions say, use the factor theorem and the given binomial to completely factor the polynomial function, then give the zeros. Basically, you've done this already. I mean, you kind of did that on your quiz. Or you didn't kind of do that. You did do that. We just didn't call it the factor theorem, right? But x plus 5, we're still going to see if it's a factor. If I get 0, then I know I've got it factored, but then I can keep going, and that's what we're going to do here. So we've got this is going to be a -5 out here. Yeah, we're starting at 6 because we don't need to do all these. Yeah, then we're jumping to 78. We're going to jump really far ahead. So then we get 3, 5, -42, 40, and 0. So this comes down at 3, -15, -10, 50, 8, -40, 0, 0, 0. So what that tells me is that x plus 5 is a factor. So that means I have it semi-factored already. This is equal to x plus 5 times, this is 4 terms, which means it's cubic. So 3x cubed minus 10x squared plus 8x. Okay. Then what can I factor out of this second part? X. It's going to be x times x plus 5 times 3x squared minus 10x plus 8. All right, so then you factor that last trinomial on your own. Oh, I factored an x out of here. The GCF, I just put it in the front. Yeah. It doesn't have to be in the front, but for me, if it's not in the front, then I lose it in the parentheses and stuff. Okay, so yesterday I talked a little bit about, you can do your grouping or divide and slide or whatever it is you want to do with factor as long as it's correct, and I'm good. But some of you, and only those of you that are really strong in factoring, those of you that are like, I'm doing grouping and I have to do grouping, that's fine. Absolutely fine, okay? But I know there are some of you that can start to look at this a little bit differently so that you don't have to go through those steps. So I'm going to talk you through this again, because I have all of this done before I even think about numbers. I know that this has to be 3x and x. Since this is positive, these are the same. Since this is negative, they're both minus. Then the numbers that go here, like I'm not doing 3 times 8 and getting 24. You can, that's a different process, okay? But that's not part of this process. We're not multiplying 3 times 8 at all. These two numbers are going to have to multiply to give me 8. So my only choices are 1 and 8 or 2 and 4. So if I put 8 here, that's going to give me a 24. I know I don't want that. And then if I put 1 here and 8 here, that's going to give me 3 and 8, which is 11 and not 10. So I know it has to be 2 and 4. So if I put 4 here, that's going to give me 12, and then I'm going to have to add the negative 2, basically, so that's too much. So this has to be 2, and this has to be 4. Then I check myself. Negative 4 times negative 2 is a positive 8. And 3x times x is 3x squared, but that's not all you can check. This gives me a negative 4 and a negative 6, that's where my negative 10x comes from, okay? So it's more about a number sense reasoning thing. If you totally don't get that at all, don't go down that road. Just keep doing what you're doing and it's fine. I'm not saying anybody has to change, but I'm just saying for some of you, you'll start to just notice that you can see it and figure it out and you don't have to go through all those steps every time. But don't do it at the risk of getting everything wrong, right? So that's your fully factored form. Then what's your smallest zero? Negative 5. So we got negative 5, then 0, then 4/3, then 2. Okay. What questions do you have? None? Okay, good. Then y'all do 78. You know the ones with the really high numbers are the really hard ones, right? They've always put them at the end. figure out what she did? Yeah? Okay. What are you doing? Why you got a square root under there? This is not fully factored. You have to factor it all the way. Factor, factor, factor.
I don't know why.
I don't know either. Well, I do, because you don't have it factored, and then where you don't even have it factored. Where?
Right here. So
That is not factored, dear.
well, it's 4, and then I broke it down in the Google.
Right, but you didn't finish it. Factor it all the way. It has to be this, like this right here, all the way out. Don't just don't copy mine. You factor it yourself. Okay, I'm going to come around and make sure that you all get it. That is the answer. You can double check. Make sure you read the directions on the assignment.